Alright, so we're going to start talking about bits and bytes and binary. Bits are the smallest piece of information that a computer can take, and they're usually shown with binary notation. Okay, binary, bi means 2, and there are only 2 values or places in binary. It's like a light switch. It has an on and an off, a 1 or a 0. And that's the simplest sort of language that a computer understands. The 1 is on and the 0 is off. So how we write binary is usually there are 8 spaces, because in a byte there are 8 bits. Each space is either going to have a 1 or a 0 here. It's either going to be on or off, present or not present. If there's a 1 here, you say yes, you count this. If there's a 0, you don't count that value. This one means 41, and I'll explain how it means 41 right now. How you decode binary is in each space there is of the 8, it represents 2 to a value. 2 to the 0, 2 to the 1st, 2 to the 2nd, all the way down to 2 to the 7th. And I've put those values corresponding with the places and their actual mathematical equivalent. If I have a 1 in this space, I don't know if you can see my mouse, but I'm on the 2 to the 0. If this had a 1 and all of the other ones had zeros, it would mean count this space, which would mean the value is 1. On the other hand, if they were all zeros except for here, with the 2 to the 4th and the 16th, I'll draw a shape around that to show you. This one, if this had a 1 and everything else had a 0, it would just be 2 to the 4th, 16. So starting with an actual example, count this one, and this one as it says. This value is present, so you count a 1. This is a 0, so we're not counting this. We're not counting this. This has a 1 here, so it's present. We count that. Not this. We count this one, and not these last 2. 2 to the 0 is 1. This is an 8, and this is a 32. You just add these values together. 32 and 8 and 1 equals 41. That was this example up here. Now you guys know how to count it.